And welcome again. We have another situation in which we are going to take the free and undamped oscillations of a system with 2 degrees of freedom. It is commonly known as two-body problem in classical physics. And we have a statement of the problem like two balls of same mass m connected by an unstretched spring of length L naught and a stiffness, that is a spring constant K, lies on a smooth horizontal surface. A constant force F directed along the axis of the spring begins to act on one of the balls. Determine the laws of motion of balls as well as the law of change in the length of the spring. Well, we are going to make a diagram first, and suppose that we have two balls like this and a spring connected to them. They are all placed on a smooth horizontal surface, and suppose a force is applied on this block, and since both got same mass, we are going to take a positive x-axis like this, and this is force F, and I'm going to take a positive x-axis like this, and this is force F, and I'm going to put coordinates as x1 and x2 to these blocks. And we are going to solve this problem in laboratory inertial frame that is attached to the earth. The frame is at rest with respect to the ground, and as you can see, I applied the force F to the ball in front, and I defined my x-axis, and we can find many more things after using it. And we know that during the motion of the balls, a spring forces act on the balls, and we will assume that the spring is massless. Then the elastic forces applied to different balls are equal in magnitude, opposite in direction, and we would like to write the equation of motion of the balls along the x-axis, and so I'm going to write it with the left ball, and that will be going to be the forces acting on it is a spring force towards the right, and that will be the length of the spring, that is x2 minus x1 minus natural length of the spring, that is the spring force going to act on it. A spring of the length, the extension in the spring is length of the spring at this moment minus natural length of the spring, and this will be equal to mass into acceleration, that will be d2x1 by dt square of the left block. And then I'm going to write the equation of motion of the right block, and you can see force F is acting in positive x-axis, along the positive x-axis, and the spring force in the opposite direction, and this will be definitely equal to x2 minus x1 minus L naught, and we are going to write down its acceleration as d2x2 by dt square, and we gave it equation number 2. x1 and x2 are nothing but coordinates of front and rear balls, and in these equations you can see two things, you can watch two things, that length of the spring at any time t can be x2 minus x1, this can be given like this, and position of center of mass of the object can be written as simply x2 plus x1 by 2. Both have same mass. So m1 x1 plus m2 x2 divided by m1 plus m2 becomes x1 plus x2 by 2 or x2 plus x1 by 2. And you can do one thing. You can subtract the equations. You can either do it by doing 1 minus 2 or 2 minus 1. I'm going to do it by make subtracting equation 2 minus equation 1 equation 2 equation 1 from equation 1, and I'm going to get some result like from the left hand side. You can see you can get f minus 2k x2 minus x1 minus l0, and in the right side you can write it here like m d2 x1 plus x2 no, so I was subtracting it, so not adding, so you will get 2 minus 1, that means d2 x2 minus x1 upon dt square. And we can use this thing as well, so that it becomes f minus 2k l minus l0 minus equal to m d2l by dt square. And then I can write this equation as I need to manipulate this equation or write in a convenient form. So I can see first thing that I can write it as well, 2k l minus l0 equals m d2l minus l0, because it will eventually become d2l by dt square because l0 is a constant. So it becomes like this, and this is not my problem. I have equation something like m, so that I can write here f upon m minus 2k upon m l minus l0 equals d2l minus l0 upon dt square. I have some equation like d2x by dt square equals minus omega square x plus c constant. So to solve such kind of problems, we usually take minus omega square as common here, so that we can write this equation like this, so that our d2x by dt square becomes d2x minus c by omega square, because it's a constant. So we can write d2x by dt square equals d2x minus c by omega square dt square equals minus omega square x minus c by omega square, and we read it like d2y by dt square minus omega square y, or d2z by dt square equals minus omega square z, and work accordingly. So using this practice, I am going to transform the whole equation like this. This is our c and this is our x, and this is our omega square. So I'm going to take common as minus 2k by m, and the left hand side of the equation becomes minus f by m and 2k by m equals d2l minus l0 by dt square. It becomes something like minus 2k by m l minus l0 minus f by 2k equals d2l minus l0 upon dt square. so that I can write it like this: minus 2k by m L minus L naught minus f by 2k equals this. Right hand side can also be written as L minus L naught minus f by 2k, because this whole thing will turn out simply as d2L by dt square, because L is the only variable here, the rest are constants. So this is my equation, and if I can put L minus L naught minus f by 2k as simply as z, then this equation has the form d2z by dt square equals minus 2k by mz, so that the equation becomes d2z by dt square plus 2k by mz equals 0. And we know that solution to this equation is simply z equals a cos omega t plus phi naught, or a sin omega t plus phi naught dash, or a cos omega t plus b sin omega t, like this we could write. And here we got omega equals simply as 2k by under root 2k by m, you can see here. And the amplitude and the initial phase, that was phi naught, are determined by the initial conditions specified in the problem. As you can see, x1 at t equals 0 was minus L naught by 2, and x2 at t equals 0 was L naught by 2. I'm assuming here that the length of the undisturbed spring was L naught, and it was initially unstretched or compressed. So we can write something like this, and we have also dx1 by dt at t equals 0 equals 0, and in the simple manner dx2 by dt at t equals 0 was also equal to 0. So we have got these equations, and you can solve the rest of the problems, and you can get your results as well. Thank you very much for watching.